Okay, good afternoon to one and all. This is Gopi Krishna, Assistant Professor, Department of Computer Science and Engineering from Chevrolet Engineering College. Subject is compiler design. So today we are discussing the topics are derivations, parse trees, and parsing, and ambiguous grammars, and the elimination of ambiguity that are present in a grammar. So these topics we are covered so far today. So in previous class, we are discussing what is the role of a parser and what is the context-free grammar and how to what are the error recovery strategies. So what is the role of parser? The main aim or the role of parser is so it is a second phase of a compiler design. So compiler design lo second phase and this parser is used to can take the output occurred in a lexical analysis that is stream of tokens. Those stream of tokens can taken as the input to the syntax analysis or parser. So we can convert those stream of tokens into a parse tree. Okay, so that is the main aim of parser. Okay, so here we are using parser, we can generate token. So in lexical analysis, each and every character that can be scanned by the lexical analyzer, and we can get the tokens and forward to the parser. So in the same way, we are going to collect all the characters that is present in our source program. We can convert those source program into stream of tokens. Those stream of tokens can take as a parser, and that parser is used to convert the stream of tokens into parsing. Okay, so this is the main aim of role of parser. Okay, so in this we are discussing top-down parser and bottom-up parser. We are discussing in previous class and what is the elimination of left recursion, how to eliminate the left recursion, that is the uses of grammar or a canonic representative grammar. So that is the elimination of left recursion, and we are using some syntax error handling. So syntax error handling, we are having three errors. Those are lexical errors, syntactic errors, semantic errors, and logical errors. What is lexical errors? So it is a misspelling of some identifiers or tokens that are present in our source program. That is the lexical error. And in syntactic errors, that is if for example we are having some arithmetic expression, so those arithmetic expression which is not having unbalanced parentheses are in misplaced semicolons, so that is present in a syntactic error. So coming to semantic errors, so this is a some type mismatches that are present in our source program, that is called the semantic errors. And what are the logical errors? So we are using assignment and equality. So there is no there is a difference between equality relationship and assignment operator. So we are having those type of errors are called the logical errors. And this error recovery strategies, we are using panic mode recovery, phrase level recovery, and error productions and global corrections. So these are the topics we are covered in the previous class. So now we are discussing in today we are discussing what is a derivation and what is the parse tree or what is parsing and what is the ambiguous grammar and how to eliminate the ambiguity that are present in our grammar. So in this so this is the derivation. So what is a derivation? So what is the definition for the derivation? So the definition for the derivation is the process of generating a terminal string, right? The process of generating a terminal string. So why? Because so we are having some grammar, context-free grammar. Those context-free grammars, the productions is in the form of capital A is production with V union the whole star, where V is the set of non-terminals and T is the set of terminals. Those are the production format for the context-free grammars. Whenever you are giving a context-free grammar, those context-free grammar can generate a terminal string. So we can develop a derivation. Okay, so the process of generating a terminal string from the start symbol. So start symbol nunchi we have to generate a terminal string of the given grammar that we are applying some sequence of substitutions is known as the derivation. Okay, what is the definition for the derivation? So derivation means so the process of generating a terminal string from the start symbol of the given grammar by applying some subsequent subsequent substitutions is known as the derivation. So that is called the derivation. So in this derivations we have two types of derivations. So first one is the rightmost derivation and second one is the leftmost derivation. So what is the leftmost derivation and what is the rightmost derivation? So coming to leftmost derivation. So in this leftmost derivation, in the derivation process at each step, so we are generating a derivation tree or a derivation. So we are considering each step on the we are replacing each step in the leftmost. So that is the leftmost derivation. So that means what is the definition for leftmost derivation? In the derivation process, at each step we replace the leftmost non-terminal by one of its alternatives. So one of its alternatives to replace this, that is the leftmost derivation. So that is the leftmost derivation. What is the rightmost derivation? In the same way, leftmost derivation, we are in a derivation process. At each step, we replace the leftmost non-terminal by its alternative. Okay, rightmost non-terminal we are replacing with its alternative. That is called the rightmost derivation. So, for example, let us consider one example. Here, here is the example. So, E is production with E plus E, or E is production with E star E, and E is production with minus E, and E is production with E with within the brackets, and E is production with ID. So here E is production with E plus E is one production one. This is production two. This is production three. This is production four, and this is production five. So we are derivations for this ID. So this is the terminal string, right? So this is the terminal string. So we can get this terminal string. So we can generate by using a derivation. So E is production with first of all we are writing minus E. Why? Because we are having the symbol. So that is the operator. So minus. So minus E is we are taking, and then in within the brackets ID plus ID. So in this ID, so E is replaced with brackets. So that E is replaced with bracket E, and this E again replaced with E plus E. Then E first E is replaced with ID, and second E is replaced with again ID. So we are using leftmost derivation. Why? Because we are applying the first leftmost non-terminal with by its alternatives. So this is the derivation for the given this string. Okay. So what is the derivation? The process of generating a terminal string from the start symbol of the given grammar applying sequence of substitutions. By applying sequence of substitutions is called the derivation. Okay, sequence of substitutions is called the derivation. So here we are having two derivations. So leftmost derivation as well as rightmost derivation. So right. So definition: the productions are treated as rewriting rules to generate a string. So ఒక string ని generate చేయడానికి మనం కొన్ని rules ని కనుక జనరేట్ చేసుకుంటే దాన్ని ఏమంటారు? Derivations అంటారు. So this is the given grammar. So E is production with E plus E. So this is one production, and E is production with E star E. This is another production, and E is production with minus E, and E is production with in brackets E, and E is production with ID. So we are having five productions: first production, second production, third, fourth, and fifth productions. We are having the same start symbol E. So this is the derivation given. So this is the derivation for the given string. So this is the given string. We are converting. We are deriving a string. So E is taken. and E is replaced with minus E, and this E is replaced with within the brackets E, and this E is replaced with E plus E. This E is replaced with ID, and next E is replaced with ID. So this is the derivation of a given string. So in this derivation, so we are having different strings. So that is called, for example, ID plus ID plus ID. So we are taking that we are having different derivation trees. Okay, so that is here is, so this is the parse trees. So what is a parse tree? Okay, so what is parse tree? So before going to discuss parse tree, so what is parsing? What is parsing? So parsing means the process of constructing a parse tree. Okay, parsing means ఒక పార్స్ ట్రీని ఎలా కన్స్ట్రక్ట్ చేస్తున్నామో దాన్ని పార్సింగ్ అంటారు. సో దీనికి టూ అప్రోచెస్ ఉన్నాయి. సో ఫస్ట్ వన్ ఇస్ ద టాప్ డౌన్ పార్సింగ్ అండ్ సెకండ్ వన్ ఇస్ ద బాటమ్ అప్ పార్సింగ్. సో what is top down parsing and what is bottom up parsing? So what is top down parsing? If the parse tree is constructed starting from the root node. So మనం ఒక parse tree కన్స్ట్రక్ట్ చేస్తున్నామంటే అది ఎక్కడి నుంచి స్టార్ట్ అవ్వాలి? రూట్ నోడ్ నుంచి అవ్వాలి. సో దట్ మీన్స్ టాప్. సో టాప్ లో ఉండేది ఏంటిది? స్టార్టింగ్ సింబల్, దట్ ఈస్ ద రూట్ నోడ్ అండ్ ప్రొడ్యూసెస్ towards leaves, that is the top down parsing. So coming to bottom up parsing, the if the parse tree is constructed starting from the leaves, so that means leaves means by using terminals నుంచి స్టార్ట్ అవుతుంది, అంటే బాటమ్ నుంచి స్టార్ట్ అయితే దాన్ని బాటమ్ అప్ పార్సింగ్ అని చెప్పి చెప్పుకుంటాం. ఓకే, సో దీస్ ఆర్ ద two approaches for the parsing. So top down parsing and the second one is the bottom up parsing. So what is parse tree? So what is parse tree, or what is derivation tree, or what is syntax tree, or generation tree, production tree? So different types names for the parse tree. So what is the definition for the parse tree? So here the graphical representation of a derivation of a terminal string. So graphical గా, so we are representing in graphical. So ఇలా రిప్రజెంట్ చేయడాన్ని ఏమంటారంటే parse tree అంటారు. So the graphical representation of a derivation of a terminal string from the given context free grammar is known as the derivation tree. Okay na? So the graphical representation of a derivation. So here is the derivation. So this is generating by using graphically. So that is the called the parse tree. What is parse tree? The graphical representation of a derivation of a terminal string from the given grammar is known as the derivation tree or parse tree. Okay, so for example, let us consider in previous case, so derivation is minus of id plus id. So this is a given string, and we can convert this string as into parse tree. So in previous we are using E is production with E minus E, and this E is replaced with in brackets E, and this E is replaced with E plus E, and this E first E leftmost E replaced with ID, and next replaced with again ID. So that is the generation of a parse tree. So here, so first E is replaced with minus E, right? So first E is replaced with minus E. So it's a minus E, and this E is replaced with again it's in the brackets with E, and again this E is replaced with E plus E, and this E is replaced with ID. This E is replaced with ID. So finally, what is the yield of a parse tree? What is the meaning of yielding? What is the meaning of yield? Yield of a derivation tree? The sequence of leaves from the derivation tree. So derivation tree నుంచి sequence of leaves. Leaves అంటే ఇవే కదా. So here is the leaves. So this is the first leaf, and second, third, fourth, and fifth, and sixth. So this is the leaves of the derivation tree. So what is the yielding of derivation tree? The sequence of leaves from the derivation tree that constitutes a terminal string. So మనం terminal string కనుక ఫైనల్ గా డిఫైన్ చేయగలిగితే దాన్ని yield of a parse tree అని చెప్పుకుంటాం. సో హియర్ ఇస్ ద what is the yield of parse tree? Minus bracket id plus id and we are having id. So this is the yield of a given parse tree. Okay, so this is the parse tree. So what is the definition for the parse tree? The graphical representation of a derivation of a terminal string from the given grammar is known as the derivation tree or a parse tree. So this is the definition for the parse tree, and here is the construction of parse tree for the given string of a given grammar. Okay, next one. What is ambiguity? What is the ambiguity? So what is the meaning of ambiguity? What is the meaning of ambiguity?
Confusion.
Huh? Anyone? What is the meaning of ambiguity?
Confusions.
Confusion, sir.
Confusion state వెళ్తున్నాం.
So the general term for the given. So in terms of formal languages and automata theory and compiler design, so the definition for the ambiguity means we are constructing two or more derivation trees or a parse trees కనుక generate చేసి దాన్ని ambiguity అంటారు. So that is the right answer. But so in terms of formal languages and automata theory and compiler design, so ambiguity is a so for some strings, there exists more than one parse tree. So that is the definition for the ambiguity. So or more than one leftmost derivation అన్న ఉండొచ్చు, లేకపోతే or more than one rightmost derivation అన్న ఉండొచ్చు. So that is called the ambiguity. So what is ambiguity string and what is ambiguous grammar? So ambiguity string, ambiguous string అంటే ఏంటి? What is ambiguous grammar? What is ambiguous string? A terminal string which has two or more leftmost derivations or two or more rightmost derivations. So ఒక స్ట్రింగ్ తీసుకుంటే ఆ స్ట్రింగ్ కి టూ ఆర్ మోర్ లెఫ్ట్ మోస్ట్ డెరివేషన్స్ ఉంటే లేక ఆర్ టూ ఆర్ మోర్ రైట్ మోస్ట్ డెరివేషన్స్ ఉంటే దాన్ని ambiguity ఆఫ్ స్ట్రింగ్ అంటారు. అంటే ఒక స్ట్రింగ్ తీసుకుంటే దానికి రెండు లెఫ్ట్ మోస్ట్ డెరివేషన్స్ రెండు లేదా అంతకన్నా ఎక్కువ లెఫ్ట్ మోస్ట్ డెరివేషన్స్ ఉండొచ్చు, లేకపోతే ఓఆర్ఆర్ రెండు లేదా అంతకన్నా ఎక్కువ రైట్ మోస్ట్ డెరివేషన్స్ ఉంటే వాటిని ఏమంటారు? యాంబిగియస్ స్ట్రింగ్ అని చెప్పుకుంటారు. సో వాట్ ఈజ్ యాంబిగియస్ గ్రామర్? సో యాంబిగియస్ గ్రామర్ అని చెప్పాలంటే ఏం చెప్తారు? ఏ గ్రామర్ విచ్ జనరేట్స్ అట్లీస్ట్ వన్ యాంబిగియస్ స్ట్రింగ్. అట్లీస్ట్ వన్ యాంబిగియస్ స్ట్రింగ్ కనుక ఉంటే దాన్ని ఆటోమేటిక్ గా యాంబిగియస్ గ్రామర్ అని చెప్తారు. సో దట్ ఈస్ ద ambiguity. ఓకే, సో in terms of ambiguity, so for some strings there exists more than one parse tree, that is called the ambiguity, or more than one leftmost derivation or more than one rightmost derivation. So let us consider an example, id plus id star id. So this is the example to construct a ambiguity trees. So we are constructing having the given input string id plus id star id. So which is the grammar is e is production with e plus e, and e is production with e star e, and e is production with id. So this is the given grammar for this ambiguity. So ఇక్కడ grammar రాయలేదండి. grammar ఏంటంటే e is production with e plus e, and e is production with e star e, and e is production with id. So that is the given grammar. So that grammar can generate two derivation trees. So that is the two parse trees. Derivation tree or parse tree or syntax tree, both are same. Okay, so we are constructing this one. So e is taken, so e is production with e plus e, and we are writing left recursion. So left we are using left production. So rightmost derivation. So we are replacing rightmost non-terminal with its alternative. So this is the rightmost non-terminal. So this is replaced with given string. So e star e, and this is replaced with id. This is replaced with Finally, what is the yielding of given parse tree? So id plus id star id. So this is the given input string. So this is one derivation tree. And coming to another, so here E is the starting symbol and it is the root of the parse tree, and E is replaced with E star E star E, and this E is replaced with again. So this is the we are replacing the leftmost derivation. So we are replacing at each step we are replacing left non-terminal with by its alternative. So that is the leftmost derivation, and it is the rightmost derivation means we are in each step we are replacing right non-terminal by its alternative. So it is the leftmost derivation and it is the rightmost derivation. So we are replacing E replaced with E plus E, and so this is replaced with ID and this is replaced with ID. So finally, what is the yielding of this parse tree? So ID plus id and star and id. So we can get the given string. So this is the given string for the grammar. E is production with E plus E, and E is production with E star E, and E is production with id. So this is the given parse trees. Okay, so then how to so we are using this ambiguity, so we can eliminate the ambiguity. So we are using to construct a parse tree for the compiler design. So మనం compiler design చేసేటప్పుడు మనం parse tree ని ఒక్కదాన్నే జనరేట్ చేసుకోవాలి. Why? Because so one parse tree is taken as a output and that is given to the semantic analysis. సో ఒక్క పార్స్ ట్రీ మాత్రమే మనం ఇవ్వాలి. సో అది ఇవ్వాలి అంటే మనకి ఎలా ఉండాలంటే ఆ పార్స్ ట్రీ అనేది సో పర్ఫెక్ట్ గా అంటే ఏమి ఎర్రర్స్ లేకుండా ఒకే ఒక్క పార్స్ ట్రీ అనేది అవుట్పుట్ రావాలి. ఆ అవుట్పుట్ అనేది మనం సిమాంటిక్ అనాలిసిస్ కి ఇవ్వాలి. సో ఇన్పుట్ గా ఇవ్వాలి. సో అలా ఇవ్వాలి అంటే వీ హ్యావ్ టు ఎలిమినేట్ ద అంబిగ్యూటీ. సో అంబిగ్యూటీని ఎలిమినేట్ చేయాలి. సో హౌ టు ఎలిమినేట్ ద అంబిగ్యూటీ? So in this elimination of ambiguity, for example, let us consider one grammar. So here is the grammar. In previous class we are discussing. So E is production with E plus E, and E is production with E star E, and E is production with id, and so this is the given string id plus id star id, and here is the another string id plus id plus id. So here what is the different how to construct a derivation tree? So in derivation tree we are constructing leftmost derivation or rightmost derivation. So two leftmost derivations or two rightmost derivations, or one leftmost one rightmost, anyone. So more than one parse tree, that is the ambiguity. So here in this string, so we are having the parse tree like this. So E is production with E plus E first. Okay, E is production with E plus E, and this E is replaced. So this means we are using left right rightmost derivation. So E is production with E star E and ID. So this is the yielding of. So this is the correct one. Why? Because so in this ID plus ID star ID. So in this string, we are eliminating the ambiguity that are present in a grammar. So a grammar lo ambiguity undi. So these two derivations for the same string, and this is the ambiguous grammar. So to remove this ambiguous grammar, sorry, to remove the ambiguity in that particular grammar, we are using one some rules. So there is no rules for the construction of given parse tree, given context free grammar is ambiguous. So we have to follow some conditions. Okay, so what are the conditions means? So in these conditions, so id plus id star id. So in the string, what is the highest precedence operator that is present in the given string. So in the given string, ID plus ID star ID. Any doubt? Anyone?
No, sir.
Right. Okay, okay. Mute yourself. Mute yourself. 506. Five not six. Okay, right. So in this grammar, we are using two derivations, right? So in this two derivations, so which one is correct and which one is wrong? Why? Because so in this string, so what is the highest precedence? So we are taking the ambiguity from bottom to top. So bottom నుంచి top చూసుకుంటే, so highest precedence is the bottom, at the level bottom, and that is remaining. So that means so first id star id can be multiplied, then this result is added to this id. So this is the correct statement or not? Why? Because so star having the highest precedence. So we are having these two ids are multiplied and the result is added to this one. Okay, చెప్పమ్మా. మా డౌటా? Doubt? Right. So here id star id. So this is multiplied and the result is added to this id. So in this leaves from bottom to top, we are discussing so bottom of parsing. So this result is multiplied and this result is added to this one. So this is the correct one. Why? Because here in this statement we are adding at leaf level this id with this id and then multiplied with the id. So this is the wrong statement. Why? Because in the given string we are having the precedence, highest precedence star. So first we are following from left to right. We are process the star, and id star id is the correct one. So this one is correct, and this id and star id is multiplied and that result is added to this id. So this derivation tree is correct. So why? Because this one is wrong. Why? Because so first id plus id is added and the result is multiplied with the id. So this is the wrong derivation tree. So we have to remove the ambiguity. So this is a not a correct statement. So here is another statement, another string, that is id plus id plus id. So in this id plus id plus id. So here from left to right, in left to right we are having id plus id. So left నుంచి రైట్ కి వెళ్తున్నాం కాబట్టి అక్కడ ప్రెసిడెన్స్ ఏమున్నాయి, రెండు ప్లస్లే కాబట్టి లెఫ్ట్ నుంచి రైట్ కి మనం ఎవాల్యుయేట్ చేస్తాము. సో ఎవాల్యుయేట్ చేసేటప్పుడు సో ఏది కరెక్ట్ అవుతుంది? ఫస్ట్ ఐడి ఈజ్ యాడెడ్ విత్ సెకండ్ ఐడి అండ్ దెన్ దట్ థర్డ్ ఐడి ఈజ్ యాడెడ్ టు these results. So this one is correct. Why? Because at the leaf level we are adding first two IDs. So here in this leaf level we are adding second ID and third ID added first and then added to first ID. So this is the wrong way. Why? Because so from left to right we are adding first and second IDs first and then add the third one. So this is the ambiguity. So we are eliminating this ambiguity. So this is the correct one, this is the correct one. So these two derivation trees for the are wrong. Why? Because so here we are having some ambiguity there. So we can eliminate this ambiguity. So we are using to replace some rules. So for example, what is the ma 524 చెప్పమ్మా. డౌట్ ఏం లేదా? ఏం లేదా? ఓకే. So we can eliminate this one. So we can eliminate the ambiguity. So we are using some rules. So our rules, our conditions ఏంటంటే, సో మనం ఆ స్ట్రింగ్స్ ని తీసుకునేటప్పుడు ఆ స్ట్రింగ్స్ ఏవైతే ఉన్నాయో ఆ స్ట్రింగ్స్ ఎట్ బాటమ్ టు టాప్ అనేది ఎవాల్యుయేట్ జరుగుతూ ఉండాలి. సో దిస్ ఐడి, సో హియర్ ఐడి ప్లస్ ఐడి ప్లస్ ఐడి. So we are using the grammar. So this grammar can be changed. So this grammar is changed to E is production with E plus ID. So this E is replaced with ID. Okay, all of you note down. So this ID is production with E plus E. So this E is replaced with ID or ID అని తీసుకుంటాం. అలాగే సో ఇక్కడ ఓన్లీ ప్లస్లే కాబట్టి సో దట్ ఈస్ ఎనఫ్. సో ఈ ప్రొడక్షన్ విత్ ఈ ప్లస్ ఐడి ఆర్ ఐడి. సో వీఆర్ హ్యావింగ్ ఓన్లీ వన్ డైరెక్షన్. సో ఎదర్ ఇట్ ఈస్ లెఫ్ట్ డైరెక్షన్ యూ కెన్ గో. సో లెఫ్ట్ రికర్స్ చేసుకుంటే ఆ లెఫ్ట్ డైరెక్షన్ లోనే మూవ్ అవుతుంది. సో దట్ ఈస్ వన్ వే. సో వీఆర్ ఎలిమినేటింగ్ ద దిస్ ambiguous grammar in this string. So we can write E is production with E plus ID or ID. So that is the finally removing of ambiguity that is present in a given grammar. So in this string, so ID plus ID star ID. So ID plus ID star ID. So we are having some statements. So E is production with E plus T we are replacing. So E is the expression and T is the term. E is the expression and T is the term we are using. So in this one one minute. So in this one we are replacing E plus T. So E plus T means, so here is the ID plus ID star ID. Okay, so in for root node, so plus is the first. So we are eliminating the ambiguity from downwards, so the bottom to up, bottom of parsing. So we are having the star is at the bottom level, at leaf level. So we are using that one. So we can eliminate this one. So E is production with E plus T or T, and T is production with T into F, and F is production with ID. So this is the way we are replacing that grammar into unambiguous grammar. Okay, so this is the elimination of ambiguity that are present in our grammar. Okay, so here is the elimination of ambiguity. So for example, here is the statement. So statement if expression then statement. సో ఇలా ఉంటే అంటే ఇన్ ద గ్రామర్ ఒక ఎక్స్ప్రెషన్ కానీ ఒక స్టేట్మెంట్ కానీ ఇలా ఉంటే, సో సేమ్ ప్రీవియస్ కేసులో ఇలా ఉంటే గ్రామర్ని, ఆ గ్రామర్లో మనం ఈ ఈ ప్లస్ ఈ బదులు ఈ ఈ ప్లేస్లో ఏం చేస్తున్నాము, టీఆర్ టీని రీప్లేస్ చేస్తున్నాం. సో టీఆర్ టీ రీప్లేస్ చేస్తే, సో నో నీడ్ టు గో టు అగైన్ ఈ, మళ్ళీ ఈకి వెళ్ళటానికి ఛాన్స్ ఉండదు. సో దిస్ ఈజ్ రీప్లేస్డ్ విత్ టీ. సో దీన్ని టీతో రీప్లేస్ చేస్తే అగైన్ ఈ వచ్చే పాసిబిలిటీ లేదు. ఎందుకు, ఈని ఐడి చేసేస్తాము, ఇక్కడ ఈని మళ్ళీ ఈతో రీప్లేస్ చేసాం అనుకో ప్రాబ్లం వస్తుంది. సో దిస్ ఈజ్ రీప్లేస్డ్ విత్ టర్మ్, టీతో రీప్లేస్ చేస్తున్నాము. సో సో ప్రీవియస్ వెళ్ళడానికి పాసిబిలిటీ ఉండదు, అందుకనే ప్లస్ ఒకసారే రన్ అవుతుంది. సో స్టార్కి వచ్చేసరికి టీ ఇంటూ ఎఫ్ అవుతుంది. ఎఫ్ అనేది ఐడితో రీప్లేస్ చేస్తే మనకి ఆ గ్రామర్ అనేది వచ్చేస్తుంది. ఓకేనా? సో దట్ ఈస్ ద elimination of ambiguity. So this is the statement for elimination of ambiguity. Statement if expression then statement, if expression then statement, else statement, others IDs. ఓకే, సో ఇలా ఉంటే ఈ ఎక్స్ప్రెషన్స్ ఈ స్టేట్మెంట్ అనేది మనం ఆ పర్టికులర్ ఏదైతే లోయెస్ట్ ప్రిసిడెన్స్ ఉంటుందో ఆ లోయెస్ట్ ప్రిసిడెన్స్ ని ఫస్ట్ తీసుకుంటాం. సో ఎలిమినేట్ లెఫ్ట్ అసోసియేటివ్ రూల్ యూజ్ చేసి మనం మారుస్తుంటాం. లెఫ్ట్ అసోసియేటివ్ అంటే ఏం లేదు. సో మనకు ఫస్ట్ ఈ ఉంటుంది కదా, ఆ ఈని యాస్టీజ్ అలానే ఉంచి ఆ లెఫ్ట్ అసోసియేటివ్ ఈ తర్వాత వచ్చే సింబల్ ని మనం వేరే టర్మ్ తో రీప్లేస్ చేస్తాం విత్ కంఫర్టబుల్ కంఫర్టబుల్ ఫర్ జనరేటింగ్ ఏ పార్స్ అనేది జనరేట్ అయ్యే విధంగా మనకి రాసుకుందాం. సో లెఫ్ట్ అసోసియేటివ్ ఫాలో అవుతాం. సో మనకి ఇచ్చిన స్ట్రింగ్ లో వాట్ ఈస్ ద లీస్ట్ ప్రిసిడెన్స్ ఆపరేటర్, సో దాన్ని ఫస్ట్ ఎవాల్యుయేట్ చేస్తాం. సో దాని తర్వాత నెక్స్ట్ లీస్ట్ ప్రిసిడెన్స్, నెక్స్ట్ హైయెస్ట్ ప్రిసిడెన్స్, ఆ నెక్స్ట్ హైయెస్ట్ ప్రిసిడెన్స్, అట్లా స్ట్రింగ్ లో ఉన్న లీస్ట్ టు హైయెస్ట్ ప్రిసిడెన్స్ ని రీప్లేస్ చేసుకుంటూ వస్తాం. ఎప్పుడైతే ఆ స్ట్రింగ్ లో ఉన్న ఆల్ ఆపరేటర్స్ ఆర్ పారాన్సిస్ అన్ని అయిపోయిన తర్వాత మనకి ఏదైతే ఫైనల్ గా గ్రామర్ వస్తుందో దట్ గ్రామర్ ఈజ్ ఏ అన్అంబిగస్ గ్రామర్. ఓకే, so that is the unambiguity. So here is the statement appearing between the then and else must be matched. So this is the expressions we are using to elimination of ambiguity. Okay now, so for example we are considering one example. E is production with E plus E star E, or in between brackets E or I. So where I is production with small a or small b, or capital IA, capital IB, capital I0, capital I1. So I తీసుకుంటే, so we are considering a string W is equals to A star B plus A. So ఆ string తీసుకుంటే, so here is the star and plus A. So what is the what is the star and plus? So these two are the operators. So those two operators are having different precedence. So star having the highest precedence and plus having the lowest precedence. So we can evaluate B plus A, so in the top level, and star we are evaluating at the leaf level. So that is the converting of ambiguous grammar to unambiguous grammar. Okay, so that grammar is, in order to convert ambiguous grammar to unambiguous, so we can follow the precedence and associativity. So here E is production with E plus E తీసుకుంటే, so in this example E is production with E plus E. So we are replacing this E is with E, and this E is replaced with T or T. So why? Because we are replacing that term in place of capital E. That means no need to go to the next. So plus అనే ఆపరేటర్ నెక్స్ట్ రాకుండా జనరేట్ చేసుకుంటానికి, ఆ టర్మ్ అంతమటికి స్టాప్ చేస్తానికి ఇలా రీప్లేస్ చేసుకుంటూ వెళ్తే ఏ అంబిగియస్ గ్రామర్ అయినా దట్ కెన్ బి కన్వర్టెడ్ ఇంటూ అన్అంబిగియస్ గ్రామర్. ఓకేనా, సో దట్ ఈస్ ద ఎలిమినేషన్ ఆఫ్ unambiguous ambiguity that is present in our grammar. Okay, so that is the first step. So in this first equivalent unambiguous grammar production is E is production with E plus E. So that is E is production with E plus T or T. So first production, and second one, now consider the second production. E is production with E star E. So here also first left associative. So E is production with, సో ఈ అనేది రాదు, ఎందుకు? ఈని టీతో రీప్లేస్ చేస్తాం. సో దట్ ఈస్ రీప్లేస్డ్ విత్ టీ ఈజ్ ప్రొడక్షన్ విత్ టీ స్టార్ ఎఫ్ ఆర్ ఎఫ్ అనేది రీప్లేస్ చేస్తాం. సో నెక్స్ట్ దాంట్లో మనకి ఈని టీతో రీప్లేస్ చేసాం కాబట్టి నెక్స్ట్ ప్రొడక్షన్ అసలు ఈ స్టార్ ఈ అనేది కనిపించదు. సో టీ ఈజ్ ప్రొడక్షన్ విత్ టీ ఇంటూ ఎఫ్ ఆర్ ఎఫ్ అనేది వస్తుంది. సో దట్ ఈస్ ద second production. So we are converting ambiguous to unambiguous. So coming to next precedence. So what is the next precedence in highest precedence? So id place లో capital E brackets ఇచ్చాడు. సో నెక్స్ట్ హైయెస్ట్ ప్రిసిడెన్స్ అది కాబట్టి, సో దానికి మనం రూల్ అప్లై చేసాం. సో అది ఎలా రూల్ చేస్తారంటే, సో వీఆర్ హ్యావింగ్ ద ఎఫ్. సో ఎఫ్ ఈజ్ ప్రొడక్షన్ విత్ ఈ capital E in between brackets or I అనేది రీప్లేస్ చేస్తాం. సో దట్ ఈస్ ద elimination of ambiguous grammar into unambiguous grammar by using some precedence and associativity. Left associative we are we are using to eliminate the ambiguity that is present in our grammar. Okay, so that is the concept. We are eliminating the ambiguity that is present in our grammar. Okay, so in next concept, elimination of left recursion. So in next class we are discussing elimination of left recursion. So all of you know elimination of